getting me?
Yes, sir.
Okay. So that here, look at. So the and hello, those students have written there the enrollment number. Please again write. Then again write your enrollment number. Those who have written earlier, please write again. Okay. So that now today, then we have to start with our the discussion about our the transpiration, because in the last class already we have discussed about the plant and the water relationship, as well as the about the water absorption, path of water, as well as the ascent of sap. Now we have discussed about our the transpiration. Have you all written? Have you all written your element number? Have you
Yes,
all written
sir.
your element number?
Yes,
1,
sir.
2, 3, 4, 5. Okay. Now tell me, what's your idea about transpiration? If someone speak about transpiration, then what's your common idea? What's your common idea about the transpiration? Hello. If anyone asks about transpiration, what's your common idea? Then what do you understand? What? Transpiration. I'm asking about transpiration, not transportation. Hello.
Water passing out from surface of the plant.
Look at so
The
now
loss of water in the form of water vapors.
look at so now first we'll discuss about the transpiration. Transpiration is a long question for you. So first you have to start with the process of loss of water from the area living part of the plant in the form of water vapor is known as transpiration. It means the process by which water that lost from the living part of the plant in the form of water vapor is known as the transpiration. So look at now, this is the plant here. Now here, and now this leaf here, the leaf contain leaf cell. Suppose sunlight falls on the surface of leaf. Due to falling of sunlight on surface of leaf, what happen? Water which present in the leaf become hot. Due to of the heat or due to the hotness, what happen? Water become converted into vapor. So now the concentration of water vapor is more inside the leaf, and concentration of water vapor is less in the atmosphere. So there is a diffusion of the water vapor takes place from leaf into the our environment. The whole process is known as the diffusion. Sorry, then the whole process is known as the transpiration. So transpiration is the process of diffusion. Got this point? Hello. Got this point?
Yes, sir.
Yes or no?
Yes, sir.
Look at and simply, and if a plant absorbs about 100 liter of water, approximately 96 to 98% of water become lost by the process of the transpiration. Only plant keep the 2 to 4 liters of water for its use. So the transpiration is a wasteful process if we look forward with respect to the water. Okay, so that here there is an already written plant lost about 96-90% of absorbed water through the process of transpiration. After that, we have discussed about the types of transpiration. Then, according to the site of occurrence, transpiration is of three types: lenticular, cuticular, and stomatal. So, first we discuss about what is lenticular transpiration. So, and then to understand the lenticular transpiration, first you have to understand what is lenticell. Look at the lenticels are the pore which are present in the woody part of the plant, or in case of trunk. So that the small pore which are present in the bark or in the woody part of the plant known as the lenticel. So each lenticel is consist of a small chamber or a cavity. And the cavity is opened outside through a pore. The cavity is lined by some parenchyma cells known as complementary cells. The xylem of the stem become open just behind of the complementary cells. So the water from the xylem enter into complementary cell, finally into cavity, and then cavity become lined with the air. Then here, due to the air, this water become escape in the form of the water vapor. So the transpiration takes place through lenticel is known as lenticular transpiration. It is about 0.1% of the total transpiration. Got this point? Hello.
Yes, sir.
Next, we discuss about the cuticular transpiration. So that here, and one more request to you all, and then those who have written your enrollment number, please again write, because after the recording is on, then your attendance will be recorded. So please try to write again your the enrollment number. Okay. Hello.
Yes, sir.
Yes.
Hello. Okay.
Yes, sir.
Now come to the cuticular transpiration. And when the transpiration which occurs to the cuticle is known as a cuticular transpiration. Cuticle means then the cuticle is a waxy coating which present on the surface of the leaf. So the transpiration is occurs to the cuticle known as cuticle transpiration. Actually, the plant has developed the cuticle to reduce the rate of the transpiration, but still then some amount of water become lost, and by the process of the and then simply through the cuticle. And now next come to our the stomatal transpiration. And here the cuticle transpiration is about 10% of the total transpiration. And then have you ever touched the cuticle? Then and then have you ever seen the cuticle? Yes or no? Have you ever seen the cuticle? Yes or no? Have you ever seen the cuticle? Yes or no? Cuticle present where? On the surface of leaf. And when you touch upper surface of leaf, it is very fine and silky, or is waxy, but the under surface is the rough. So that the waxy coating that present on the upper surface of leaf is known as cuticle. Got this point?
Yes, sir.
Yes, sir.
Let's come to the stomatal transpiration. And then the transpiration through stomata is known as stomatal transpiration. It is about 80-90% of the total transpiration. Stomata is the plural, stoma is the singular. Now first we'll discuss about then and what are the stomata. Stomata are the minute pores which are present on the surface of the leaf. And now we have discussed about structure of stomata. Each stoma means singular. Each stoma has a pore. The pore is guided by two kidney-shaped guard cells or by two guard cells. The guard cells are surrounded by the subsidiary cells or accessory cells. The inner wall of the guard cell that present towards the pore is considerably thicker than the wall that face towards the subsidiary cells. Got this point? This is the structure of the stomata that found in our the leaf. So next we have discussed about actually and when, and here a question arises when transpiration occurs through stomata. When stomatal pore is open, transpiration occurs. When stomatal pore is closed, then there is no transpiration. So here a question arises when stomata open. Suppose you consider this a closed stomata. Suppose actually here actually here in this figure we have done the open stomata. Suppose you think that then this particular the two inner wall has become joined. Suppose it is a closed stomata, and so that to stomata to open, the OP of the guard cells should be more than OP of the subsidiary cells. So when OP of the guard cell is more than OP of subsidiary cell, water from the subsidiary cell will enter into the guard cells. So there is increase in the osmotic pressure of the, so that there is increase in Tugger pressure of the what? Look at here. And when OP of this particular guard cell is more than OP of this particular the subsidiary cell, water from the subsidiary cell will enter into the guard cell. So due to the high water content of the guard cell, then there is a considerable amount of Tugger pressure developed. So this particular two inner wall become pulled apart, stomata become open. Got this point? Hello?
Yes, sir.
Yes, sir.
Look at, now come to the mechanism of transpiration. Mechanism of transpiration also implies the mechanism of opening and closing of stomata. To explain mechanism of opening and closing of stomata, the number of theories have been proposed. And those who have newly joined, do write your enrollment number in the chat box, because maximum time you all are not writing. That's why, and then that's why you are also losing your attendance. Okay. Look at, and then to explain the mechanism of transpiration, number of theory have been put forwarded. Then you have to study this theory under follows. One is the theory of photosynthesis of guard cell, starch sugar interconversion theory, theory of glycolide metabolism, active H plus K plus transport theory. So first we discuss about theory of photosynthesis of guard cell. The theory of photosynthesis of guard cell was given by von Mohl in the year of 1856. According to von Mohl, and then during the daytime, the photosynthesis occurs inside the guard cell. Due to photosynthesis, sugar is made that rise OP of the guard cell. So water from the subsidiary cell now enter into the guard cell, that increases the Tugger pressure. The stomata become open. Got this point? Hello.
Yes, sir.
Yes, sir.
Okay. Next is the starch sugar interconversion hypothesis or theory. And then according to starch sugar interconversion hypothesis, during the daytime, and then the starch is converted into sugar. When the starch is converted into sugar, then OP of the guard cell become increase, so stomata become open. During the night time, sugar is converted into starch, so OP of the guard cell become decrease, water comes out or exosmosis occur, so stomata become closed. Look at, and then to support our the starch sugar interconversion hypothesis, there are the number of scientists came. Syre in 1926, and then Syre, then In and Tong, Lloyd, these are scientists who support this particular theory. Actually, it is very much difficult to explain and each and everything. Look at, and then first we have discussed about the most important theory that you have explained in case of the examination, and this theory is our active H plus K plus transport theory, because you have to explain this in case of the examination. Okay, so first we have to explain, and then this active H plus K plus transport theory was given by, hello.
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Look at it. Now first we have discussed about the active H plus K plus transport theory. In case of 1959, the two scientists of Japan, Imamura and Fujino, they first time reported that when stomata become open, the concentration of K plus ion is high inside this particular guard cell. And they suppose that the K plus ion might play important role in the opening and closing of stomata. But the active H plus K plus transport theory was given and advanced by Leavitt in 1972. Then we have discussed about and actually then how the stomata open and close according to Leavitt during about the day and the night time. So first we have to discuss about the opening of stomata during the daytime. And always you have to remember one condition: during the night time, the stomata remain closed. Got this point? Always you have to remember this: in the night time, stomata remain closed. Look at now here inside this particular look at night time stomata remain closed. The stomata contain the stars during the night time. In case of early morning, what present here? This particular stars who is present, the stars remain present during the early morning. But when sunlight falls on surface of leaf, what happened in the daytime? What happened? The stars first break into glucose. The glucose is converted into phosphoenolpyruvic acid by the process of glycolysis. This phosphoenolpyruvic acid converted into malic acid. The malic acid dissociates into malate minus and H plus. Now look at here. Now the concentration of H plus is high inside now this particular guard cell. Then those guard cell membrane contain H plus pump. So the H plus pump, the H plus from the guard cell now pumped into the subsidiary cell. Then due to the pumping of H plus from the guard cell into subsidiary cell, then what's happened? So देखो राति बेला कौन अछि स्टोमाटा क्लोज हेक अछि सब बेले देखो जहां से पड़ो सब जगह भूली जा अभी जे राति बेला स्टोमाटा क्लोज हेक अछि राति बेला ट्रांसपिरेशन होउनी दिन बेला ट्रांसपिरेशन हबो तार तो ए राति बेला कोन होची गार्ड सेल ए स्टोमाटा क्लोज हेक अछि किंतु आ भितरे कोन अछि inside this particular the guard cell am starch अछि starch is a long chain of the glucose in the early morning body भोर भी starch अछि खरा पहिले कोन होची starch भांगुची glucose होची glucose then phosphoenolpyruvic acid then phosphoenolpyruvic acid convert malic acid convert into malate minus and H plus whatever H plus form that become pumped from the guard cell into the subsidiary cell by the help of H plus pump. So what now present inside the guard cell? बर्तमान H plus pump हो गला पर guard cell कौन रहले छुआ
malic acid
minus रहला. So guard cell become electronegative हो गला. Then to maintain the negative charge of the guard cell, then K plus from the subsidiary cell now enter into the guard cell through the K plus pump. Okay. Then what amount of K plus need? Then what amount of K plus enter? Then that is sufficient enough that required to balance the charge of the malate minus. That is जेति के हमर K plus पसिला तारा amount of बहुत अधिका as compared to the K plus required to balance the charge of the malate minus. But this point. So एबे कोन हेला को एबे गार्ड से भीतरटा कोन हेला पॉजिटिव हेला ना नेगेटिव हेला हेलो what amount of K plus required to balance the charge of the malate minus the excess K plus enter. So what would be the charge of the guard cell here right now tell me
positive
and then to balance the charge of the excess K plus then chlorine minus start to enter. Look at now the concentration of the ions like malate minus chlorine minus K plus now increase inside the guard cell. Due to that OP of the guard cell become increase. Due to increase of the OP of the guard cell, so water from the subsidiary cell enter into the guard cell. So stomata become open. For this point, those who have joined lately, please write your enrollment number in the chat box. Do write. Look at now. First we discuss about how the stomata close during the night time. In the night time, one hormone is known as abscisic acid which come into play. In presence of hormone abscisic acid, the permeability nature of the guard cell membrane becomes changed. So the K plus from the guard cell now enter into subsidiary cell. S plus from the subsidiary cell now enter into the guard cell. Chlorine from the subsidiary cell from the guard cell now enter into subsidiary cells. Means जोटा आसला से जो सेडी पळेला वर्तमान को हेबे ना OP of the guard cell become decrease. So water comes to the subsidiary cell, stomata remains closed or stomata will be closed. Understood?
Yes, sir.
Then this is about our look at this is the mechanism of the transpiration. Always you have to remember, if in the exam the question comes describe the process of transpiration, first you write the definition of the transpiration. After that this figure, then about types of the transpiration. After that you have to mention the mechanism under the conversion theory, the theory of glycolipid metabolism, active H plus K plus transfer theory. After that you have to directly explain the active H plus K plus transfer theory, and the rest of theory are not valid, and H plus K plus transfer theory is a valid theory, is the more convincing theory explaining our mechanism of transpiration or opening and closing of stomata. Okay. Hello.
Yes, sir.
Yes, sir.
So now next we have to discuss about the guttation. Water takes and in the form of the water vapor, but when the loss of water takes place in the liquid drop from the leaf is known as the guttation. So that guttation is the loss of water in liquid form in the plant or from the plant is known as the guttation. Generally guttation occurs through pore is known as the hydrator, whereas the transpiration occurs through the stomata. Look at now come here. The guttation is commonly found in which plant? About the colocasia, saru gacha, vitis, anguru gacha. Okay, saru, anguru, esu gacha, tomato, lycoppersicum. Then and in this plant, then will is hydrathor having cavity. Cavity is open outside by a pore. And then hydrathor, also known as water stomata, is the cavity of hydrathor is lined by some specialized cells known as epitheme. The xylem of the stem is now continuous with the xylem of the leaf. The xylem of the leaf is open just before the epitheme. And then guttation takes place during and then in the condition where the hot day is followed by cool night. What? दिन बेला कौन है प्रबल खरा है राति बेला ठंडा हम. Look at, and during our the daytime, what amount of water become absorbed into the root? The maximum lost in the process of transpiration. But during our night time, what amount of water absorbed? But there is continuous water absorption, but there is no loss of water. There is no transpiration as much more because of absence of sunlight. So due to continuous absorption of water during the night time, I am very
Sir, आपन voice सुबुनी.
And when you caught a plant just above the ground, hello, am I audible to you all? Am I audible to all?
Yes, no, sir. भलसे सुबुनी.
No, sir, your voice is break.
Is it now audible? Hello.
Yes, sir.
No.
ଏବେ ସୁବିଲା ସମସ୍ତଙ୍କୁ?
Sir.
हाँ sir.
ପିଲାମାନେ ଦେଖ ଆମେ ଯେ କହିଲେ କି ଦେଖ ଦିନ ବେଳା କଣ ହଉଛି ଯେତିକି ଗଛରେ ପାଣି ପଶୁଛି ମ୍ୟାକ୍ସିମମ୍ ପାଣି ସବୁ ଟ୍ରାନ୍ସପିରେସନ ବାଟେ ବାହାରି ପଳଉଛି. राति बेला कौन होची अधिक पानी पशुची कि ट्रांसपिरेशन पानी ट्रांसपिरेशन होने हमर सूर्य नाही सेति पे कौन होची जाइलेम भितरे गछ भितरे पानी बढ़ी जाउची एटा कौन गछ भितरे जो हम जो जाइलेम प्लांट अछि गछ भितरे जो जाइलेम अछि जाइलेम में वाटर स्टोर होगी रहउची अंडर हाई प्रेशर रे इफ यू कट द प्लांट जस्ट अबव द ग्राउंड तले कौन हो सब जाक पानी देखो तुम देखो सब जाक ना पिचिकली मारी बाहर पानी गुरा ताको हम कहते रूट प्रेशर एक्जेक्टली द रूट प्रेशर इज our responsible for the rotation. So due to the root pressure what happen night time रे कोन होची पानी पसुची पानी बाहर नहीं बाहर जाउनी पत्र बाटे सेटे कोन होची ए पानी गुरा कोन होची ए बाटे आसी जो जाइलेम जोटा हमर जाइलेम ऑफ लीफ बाटे पानी जस्ट बाहर जाउची टू दी एपिथेम को ए बाटे पानी सब जाक हमर ना थप थप ही पड़ुची तार तो सारू गछ जो तळ ब्लेड देखिवो जो पानी लागि गछि then that is the water that has been executed by the process of the rotation. Got this point?
Yes, sir.
Yes, sir.
And then the liquid that is lost by the process of rotation or eschewed by the process of rotation is never pure. Instead, it contains enzyme, salt of sodium, magnesium, phosphorus, and enzyme like catalase. Okay, these are the and this liquid also slightly acidic in nature. There are the two types of hydrators are present. Then one is the epithem hydrator. And second one is our active hydrators. Then rotation occurs in a plant like Lycopersicum tomato, impatiens, blasum plant, vitis, Colocasia saru. Okay, these are the example of the rotation. The next is anti-transparent. Anti-transparents are those chemical substances that reduces the rate of transpiration without inhibiting gaseous exchange, known as anti-transparent. Anti-transparents are two types. One is metabolic inhibitor antitransparent and a surface film film antitransparent. The metabolic inhibitor time means when you spray some chemical onto the plant, if this chemical that causes partial closure of stomata, so the rate of transpiration is very less, is known as metabolic inhibitor antitransparent. The examples are PMA, phenyl mercuric acetate, high carbon dioxide, ABA. Next, the film forming antitransparent. Then as like we laminate our mobile. Suppose
Sir,
we are having a certificate.
Sir, ABA कौन
Abscisic acid.
हाँ
Look at. And suppose we are having our certificate. Suppose we have laminated a certificate. If we put in water, will the certificate wet?
No.
No, sir.
No.
Just like that. And suppose we are having a leaf, and if we spray on the surface of leaf like compound like colorless plastic, low viscosity to access, etc., means they will form a thin film on the surface of the our transparent surface. So water will not escape. हेले जदि हम कोनका पत्र ऊपर कलरलेस प्लास्टिक किबा मोहमटा जदि हम स्प्रे कर दबा पानी कथा जो कणा बाहर की जीव की ता तो एंटी ट्रांसपेरेंट से जो कंपाउंड जो कंपाउंड मान ट्रांसपिरेशन को हम स्लो कर दियन गॉट दिस पॉइंट
Yes, sir.
Yes,
Yes, sir.
okay then these are the advantages and disadvantages of the transpiration. Look at the transpiration having look at due to the transpiration nearly about 96 to 98% of water that is lost that have been absorbed by the water absorption. So due to the transpiration, due to the excess loss of water, and then so that the plant will suffer from water crisis or water deficiency. Yes or no? And due to the transpiration,
Yes.
the 96 to 98% of absorbed water lost that cause water deficiency in the soil. So still then, why do the plant have in transpiration? So the transpiration रे कछ 96 to 98% of absorbed water टा उड़ाई दोची ता परे भी गछ ट्रांसपिरेशन कोन दका गछ कोन पे ट्रांसपिरेशन निज पे करूची कोन पे रखी छी ट्रांसपिरेशन तो ये ट्रांसपिरेशन होजी माटी रे पानी छोड़ जाउची झाउली गछ मरि जाउची बट व्हाई देन द प्लांट हैविंग ट्रांसपिरेशन if plant stop transpiration can plant survive? The question is arise.
No.
No. Why? Look at due to the transpiration or water absorption takes place. The transpiration control the temperature of the plant. Then during our the transpiration, a huge amount of water enter into the plant. Along with this water, some minerals like sodium, potassium, chlorine also enter into the plant. It also help in a mass flow of the ions. So if plant want, the plant cannot avoid transpiration to survive. Though the transpiration have been the disadvantages, but the plant cannot live without transpiration. If the plant the stop transpiration, avoid transpiration, the plant body temperature cannot be controlled. Our water absorption cannot take place. Distribution of food, the food material cannot occur. So the transpiration is necessary evil. Okay, transpiration is necessary evil. Means बहुत दरकारी खराब. Okay, got this point? Hello.
Yes, sir.
Yes, sir.
Look at. Then after we have to discuss about our mineral nutrition.
Sir, I have a doubt.
Okay, speak.
In a plant, we will add some wax, several to some leaves. Okay, few of them, not entirely. Few of them. What about that wax leaf? Is it a dye or it will like dead or something?
Again. Question again.
सर जदि गोटे गछरे आमे वर्क्स पके माने महम पकेबा सब गुडा न पकेकी किछिटा सपोज गोटे प्लांट रे 10टा अछि आमे सेइथरु 5टा को वर्क्स कर दबा तो सेटा रे हबनी ना ट्रांसपिरेशन तो से लीफ रो अवस्था कोन हबो मु सेटा जानिबा को चाहतली
Then in the just in the topic of anti-transparent, I had also told you the low viscosity waxes. Means anti-transparents are those compounds. They generally reduces transpiration. They slow down the process of transpiration, but without affecting gases exchange. The plant needs oxygen and a carbon dioxide and gases like that. And suppose you are having the 10 plants, according to your question, you are having the 10 plants. Suppose you have coated the 5 plants with the waxes. The waxes should be low viscosity waxes. Low viscosity means अल्प बहलर wax हेबा दरकार डेंसिटी रो जा फल रे से wax coating बाटे the oxygen and carbon dioxide should enter. If your wax is a high density wax, the plant could not transpire. After some days the plant will die. Okay.
बट मो क्वेश्चन थिला कि गोटे गछरे 10टा पत्र थिबो 10टा पत्र रो 5टा पत्र पकेइबी जो पत्र गुडा वर्क्सेस हेइथिबो तो से पत्र गुडा रे तो ट्रांसपिरेशन हबनी मो हाई डेंसिटी वाला देबी तो सेइथरे हबनी ट्रांसपिरेशन तो सेई 5टा पत्र रो कोन हबो आ से 5टा पत्र रो जहा हबो सेटा कोन अलगा ब्रांच किबा लीफ को इफेक्ट करैबो की
No. Actually in this particular and in this plant or especially and in that particular 5 leaves or suppose your photosynthesis will be affected, transpiration will be affected, finally there will be the senescence will be start. And look at the senescence means what? The process of aging.
Yes, it will leave some substance.
It will not affect other part. Ultimately, after some days, and this particular the leaf where you had applied the high viscosity waxes, this leaf will finally fall down. Okay, and it will not have the bad impact on the other part of the plant.
But in senescence, if the affected leaf will leave some substances from there, okay, that will affect or damage the healthy plants, healthy leaves, right?
No, actually, so first you have to discuss about what is senescence. Senescence are the many types are there. One is the overall senescence. Overall senescence which are found in annual plants. The plant completely die at the end of the season. Suppose the overall senescence are found in case of the rice plants. After the growing season, the complete rice plant from the root to root, stem, leaf and everything become die. then we are in the top senescence. In case of the some cases, what happened? Then the overground part of the plant remain die, but underground plant remains survive. That simply that then found in our the some tendrils, some the shrubs, and then we are having the progressive senescence. In case of the progressive senescence, what happened? The older part, they die continuously and fall off throughout the years. But here the progressive senescence will occur.
Okay.
Any doubt again?
No.
Next come to our the mineral nutrition. So and then before discuss about mineral nutrition, so first we discuss about what are the minerals. Mineral means the inorganic element present in the form of ion in soil called a mineral. Suppose you take example of the magnesium, phosphate, ammonium, chlorine, sodium plus. Then all these are the inorganic because they do not have carbon. So inorganic ions present in the soil in the ionic forms are known as minerals. So the process of absorption, distribution, and utilization of mineral by the plant for normal growth and development is known as mineral nutrition. So first you have to explain about then the definition of the mineral nutrition. Mineral nutrition means the process by which the plant absorb mineral. And let you take example of the magnesium. So magnesium is mineral. The mineral nutrition involves absorption of mineral, distribution of mineral, and utilization of mineral. Let you take example of the magnesium. And then by the process of mineral nutrition, first magnesium enter into the root. This is the absorption. After the magnesium is entered into the root, this magnesium now become transported to the part of the plant body where magnesium will be utilized. Let this magnesium is transferred to the leaf because in the leaf magnesium will become utilized. This is the distribution. Now come to the utilization. In the leaf, the magnesium now become utilized for the synthesis of chlorophyll. Because magnesium is the integrated part of the chlorophyll or the integral part of chlorophyll which is present at center of the chlorophyll. So here the mineral nutrition involves absorption of mineral, then distribution of mineral as well as utilization of mineral. Got this point all?
Yes,
Yes,
sir.
sir.
Okay. And then in nature, there are about 92 natural elements are present. And when you go for the chemical analysis of the plant ash, suppose you take a small piece of the plant and you just burn it. And when we go for chemical analysis of plant ash, we can found that the plant ash contain about 40 elements. Out of the 40 elements, and then the 16 elements which are essential for the plant, without which the plant cannot complete the life cycle, and 24 elements which are non-essential for the plant. If these elements are present or absent in the soil, the plant can complete the life cycle. So out of 40 elements, 16 are essential, 24 are non-essential elements. So first, the Epstein in 1972 gave two criteria to identify which elements are essential, which are non-essential. So that here the first condition is, look at the first condition is, if in absence of one element, if the plant is unable to complete its life cycle, is known as essential element. The second condition is, if this element forms integrated part of a biomolecule, this biomolecule is essential for the activity. For example, magnesium. Magnesium is an element which forms the integrated part of a biomolecule, that is chlorophyll. The chlorophyll is essential for the plant survival. So these two conditions are mainly are the two criteria and to justify whether an element is essential or non-essential. So that here, next come to the, and we are having 17 essential element. I haven't told you. So sorry, 16 element. 16 are essential element and 24 are non-essential elements. Look at, out of 16 essential element, we have divided the 16 essential element into the two group. One is macronutrient and a micronutrient. Macro means The elements which are required by the plant in large quantity amount is 1000 microgram per gram of dry weight, known as our, this is the mu g. This is the mu g, not mg. 1000 microgram per gram of dry weight, known as macronutrient. Out of 16, we are having the 9 are the macronutrient, one CHO, NPK, calcium, sulfur, magnesium. Always you remember that CHO are not a mineral, because carbon, hydrogen, oxygen the plant got from the environment, carbon from the carbon dioxide, H from the hydrogen, from the water, O from the oxygen. And then now comes in the micronutrient, the elements which are required by the plant in large quantity, known as micronutrient. And this quantity should be equal to or less than 100 microgram per gram of dry weight. And then micronutrient are known as the trace element. Suppose we are having a meal, I'm going to meal खाऊचे, ये meal रे rice टा हला कौन macro ना micro?
macro
माइक्रो की हबो तरकारी जा सब खाउछ तमे भजा भजा खाउछ, all are the micro. Then the micro elements are required in the very less amount. It includes chlorine, manganese, boron, G, copper, nickel, etc., as well as the iron also. The micronutrient also known as the trace element, because they are required in less amount. Now come to the general function of the minerals. Actually, what the function the mineral play in the plant? First is the formation of the plant body. As you know that the plant body is formed by mainly of these chemicals: carbon, hydrogen, oxygen, nitrogen, phosphorus. And just you exclude sulfur. आमे गोटे ओडिया रे गोटे कहू पंच महाभूत ना सुन छुआ माने वायु.
yes sir
हाँ सर हाँ
yes
सर
sir
आमे जो कहू पंच महाभूत जो कहूचे आमे जो निजर पुराण रे कहूचे जोटा को आध्यात्मिक कथा रे आ पंच महाभूत साइंस रे के CHONP, carbon, hydrogen, oxygen, nitrogen, and phosphorus. And then the second role is osmotic potential of the cell. The plant cell can absorb water when the cell having high OP, high salt. So these particular the minerals are responsible maintaining high OP. Then some minerals also maintain acidity and a buffer action of the cell also. And then especially element like sodium and calcium, they influence cell membrane permeability. Sodium promote and calcium inhibit permeability. Catalytic effect. So minerals which are required for the our hello. Am I audible to all?
yes sir
Yes,
Okay.
sir.
And
yes sir
Yes, sir.
Elements which are required as cofactor for enzyme. For example, magnesium. Magnesium acts as cofactor for the activity of DNA polymerase. Without magnesium, the DNA polymerase cannot work. So some elements are essential for the enzymatic activity. Like zinc is required for the alcoholic dehydrogenase, etc. There's some elements which are having some toxic effect on the plant cell also, like mercury, arsenic, cobalt, and these are having some toxic effect, balancing effect. And then the toxic effect of these chemicals are balanced by these elements: calcium, potassium, magnesium, etc. And these are the role. Look at, and then as per your syllabus is concerned, then you are having some important deficiency symptoms of minerals. And then that's the deficiency symptoms of the mineral. Then sometimes in the plant is not affected by any pathogen, still then the plant having some symptoms. So these symptoms are due to of deficiency of the mineral in the soil. Plant को रोग plant रे किछि रोग पको नांती कि जीवाणु नांती, still then plant रे किछि लक्षण आसुची, plant बढ़ु नै, पत्र गळी पडुची, हळदिया हेइ जाउची. And then these are due to of deficiency of mineral present in the soil. Soil रे किछि mineral ता deficiency होची, sodium, potassium, chlorine, nitrogen सुदा अभाव अछि. एबे देखिया what are the main symptoms? कोन को लक्षण जदि mineral deficiency हुए गछरे, what are the main symptoms? One is stunting. Stunting means रुगुड़िया हे जिबा, not better growth, not luxurious growth. generally happen due to of the nitrogen. Then chlorosis means loss of the chlorophyll. Generally, it happen due to nitrogen and magnesium. Magnesium present in the center. If the magnesium loss occur, the chlorosis occur. The nitrogen also forms important part of the chlorophyll. If nitrogen deficiency, there is also loss of the chlorophyll or chlorosis. Necrosis. Necrosis means localized death of the cell in our leaf. Then you might have seen some cracky area or some dead area in the leaf of atrobot trees or jackfruit, as well as in case of our citrus. So, have you ever seen the leaf of the jackfruit or the atrobot trees heterophylla?
Yes.
Yes, sir. Yes,
Yes,
sir.
sir.
गोटे कहला जो पणस गछ देखिबा पत्र देखिबो गोटे जगह पोड़ी पोड़ी जाइथिबो पोड़ी पोड़ी हे गोटे जगह झिली झिली देखा होथिबो बरफ पत्र देखिबो एला नाम नेक्रोसिस तापर हमर रखला मटलिंग मटलिंग माने को पत्रटा ग्रीन हेथिबो अटे देयर इज अ ग्रीन एंड नॉन ग्रीन एरिया appearing in the leaf मटलिंग leaf curls the apical part become curled abscission माने falling of the leaf wilting wilting माने झाउलिबा due to the loss of water, due to the deficiency of water, poor reproductive development. If there is no nitrogen in the soil, there is the poor reproductive development. Means size of the fruit, however, they also become reduced. Heart rot. The center, the morphologically or external plant remain healthy, but central part has been rot. Moji part sorry. Okay. And then after that we have discussed about some important deficiency symptoms of some minerals. Look at and then as per then for your information always you have to follow this format. In case of examination the question can become what are the macronutrient, discuss the deficiency and symptoms. So that first you write about specific role means what the role or simply what is the function of these elements in the plant. And for example the nitrogen is the important part of the protein, nucleic acid, porphyrin, alkaloids, chlorophyll, etc. Then always you have to give the more focus on the deficiency symptoms. If there's a nitrogen deficiency in the plant, then what would be the more possible symptoms? That is the chlorosis of leaves, the development of anthocyanin and pigment, the leaf turn into the various colors, the stunting growth, plant rugudi hejibo. Now come the phosphorus. As like that you have to write the specific role means about the then what is the function of the phosphorus in the plant. The phosphorus is the important part of the nucleic acid, DNA, RNA, the coenzyme, etc. If there is a phosphorus deficiency, then there is a phosphorus deficiency may cause premature leaf fall, means the young leaf will fall down. Dead necrotic area, it means the black area become appear throughout the leaf surface. Leaf may turn dark or dark to blue green in color. These are the deficiency of the symptoms of the phosphorus. Then sulfur, the main deficiency of sulfur deficiency cause yellowing or simply the chlorosis of leaves. Tip and margin of leaf roll inward, stem becomes hard due to development of sclerenchyma, etc. Then calcium, the deficiency means calcium deficiency cause disintegration of growth of growing meristematic region, means apical meristem, pseudoapical meristem and the root apical meristem become disintegrate because of the deficiency of the calcium. There chlorosis occur along the margin as like for the macronutrient as well as a micronutrient. For example, iron is a micronutrient. These are the book. Okay. Hello.
Yes, sir.
Yes, sir.
Hello. Okay. And this is about the look at now here next comes about the nutrient uptake. So the process by which the nutrient are the nutrients minerals are absorbed into plant. So what is the root here? The process by which potassium, sodium, magnesium, chlorine is a Cl minus, not 2 minus. Okay, this is a Cl minus, and they become absorbed into the root, known as the mineral nutrition. And then we are having the two types of the transport. One is downhill, second is uphill. Suppose the concentration of sodium is very low in the root, concentration of sodium is very high inside the soil, and if the mineral and if the sodium enter from the soil into the root, is known as downhill transport, from more to less, and in this case there is no energy involved. Got this point? Hello?
Yes, sir.
Yes.
And then let's come to about the uphill transport. Suppose concentration of sodium is high inside the root and a concentration of sodium is less in the soil. Still then, if the plant uses energy or ATP to transport the sodium into the root, known as the downhill or known as the uphill transport. And then downhill generally is a passive process, uphill is generally active process. This is the passive absorption, this is the active absorption. Got this point?
Yes, sir.
Hello? Then according to the direction of transport, our mineral transport is of two types, passive and active, and you have already got. Passive transport means there is high concentration, low concentration. Active means low concentration to high concentration. And then look at here. Generally, we have divided the complete transport process into two categories. That may be active or passive. One is non-mediated, second is mediated. Non-mediated means if any compound that directly enter into the cell without aid of anything, that known as the non-mediated. For example, oxygen. Here, the oxygen can easily enter into the cell without help of any protein. So this known as the non-mediated. For this point, now come the mediated. Suppose the sodium having charge, so those compounds having charge, they cannot enter freely into the cell. To enter into the cell, they have to they have to take help of some protein. So through some protein, they can enter into the cell. So known as the mediated. Got this point?
Yes, sir.
Yes.
And then look at so far we have discussed about the non-mediated. The examples are diffusion, mass flow, ion exchange, and then the Donnan equilibrium. All are the example of this. Then the mediated uptake. Mediated uptake here, when transport of the molecules or ions occur through carrier or channel or pump, is known as mediated uptake. Look at here, the mediated uptake is two types: active mediated uptake and a passive mediated uptake. Here, the passive mediated uptake occurs through ionophores, carrier, and ion channel. And always you focus on these two, the carrier. Carrier means the carrier are the membrane proteins which are present in the cell membrane. Suppose look at and suppose this is the cell, and then suppose here we are having a protein present here. This protein known as a carrier protein. It's into the cell. First, it takes the sodium ion and it direct sodium ion to enter into the cell. Again, come to the original position. Again, pick one sodium and again deliver into the cell. This is known as the carrier protein. Okay. So transport mediated by the carrier proteins are known as facilitated diffusion. Here there is no energy involved. Look at here. This is suppose this is the carrier protein. Here the K plus bind here. After the K plus bind, it brings the K plus into the cell. After the release of the K plus, again then this phase come to this place to pick another K plus. At this point.
Yes.
Next is about the ion channel. Generally, ion channel forms a pore in the membrane. This is the cell membrane. The ion channel forms a pore. Then through this pore, then the K plus or any ions can easily enter. Suppose this is the our K plus channel. So this K plus channel, the K plus now become enter into the cell through the lumen of the, and then the lumen of this particular channel. At this point, the transportation is very fast in case of the channel than as compared to the carrier. Generally, carrier are having weight 40 to 50 kilodalton kd. Okay, and then look at, and if any protein and that cause transport from the low concentration to high concentration by using energy of ATP known as the active transport, this protein is known as a pump. You have to remember this point. Okay, now tell me, and what is a pump? What is a pump? Hello, what is a pump?
So to
Sir, your
pull
voice
out
is
water.
breaking, sir.
Now tell me, what is a pump?
So which is used to pull out water from the
Not pump pull out water, and when, and when if look at, and suppose this is a cell. Okay, just look at here. Look at, now here this is our the cell membrane, then this is protein is here. The function of this protein to transfer sodium from the outside into the cell. Suppose concentration of sodium is high inside the cell, so then there is no need of the enter of sodium. Still then cell needs sodium. So but here concentration of sodium is less here. So for this transport here the normal diffusion cannot occur. Still the cell uses energy of ATP to transport sodium into the cell again. So the protein which uses energy of ATP to transfer ions into the cell known as a pump. For this point, hello.
yes, sir.
Yes, sir.
Yes or no?
Yes, sir.
Then which is a pump? Now tell me, which is a pump?
Pump is also called a transport and are uh, transport membrane protein
Then
that
you may speak
active
in
the
an old language also, mother language also. And if you are feeling uncomfortable in English, then you may also speak in your own language. Then there is no matter at all. What is a pump? What is? Who can speak? Who can speak?
It is a mediator who can transport the lower concentration particle to high concentration.
Pump is a membrane protein which transport the ions from their low concentration to high concentration. Okay, by using energy of ATP. What this point at all?
So pump we can also call active process because in active transportation they also need energy in form of ATP.
About the transpiration, rotation, mineral nutrition, etc., mineral transport also. And just you have to focus on now here the photosynthesis in some extent. Now tell me, what's the idea about photosynthesis? What's the idea about photosynthesis? What's your
This
idea
is a
about
process which plant loses water.
photosynthesis? Is a process by which plant prepare its own food material by getting carbon dioxide from atmosphere, water from the soil in presence of the sunlight and chlorophyll. Okay, plant takes carbon dioxide from the atmosphere, water from soil, and uses energy of sunlight and chlorophyll, and in presence of chlorophyll it synthesizes the carbohydrate. What is point? This is known as photosynthesis. Hello.
Yes, sir.
And next,
Yes, sir.
and the mechanism of photosynthesis can be described by two phases: one light reaction and direct reaction. And just here I'm giving the our brief idea, because as you already known that to teach only one long question, then general there about the 2 to 3 hours required, or minimum one class is required. But here we are covering the number of modules in a single class. Okay, that's why just I will try to give the brief idea about these things. So first come to in case of photosynthesis, and always you have to remember that in photosynthesis plant prepare the food material. The photosynthesis takes place by the two processes, light reaction and direct reactions. Always you have to remember that in the photosynthesis, this carbon dioxide does not combine directly to water. The maximum time we think that, and the carbon dioxide combine the water to become carbohydrate. Actually, this is not happening here. The light reaction, what happened? Water is first utilized in the light reaction. Our photosynthesis कौन होची water the light reaction हमारे utilize हुए carbon dioxide tomorrow ना direct reaction utilize हुए then number combine. Got this point?
Yes, sir.
What happened? The water becomes split, or the photolysis of water takes place, or breakdown of water takes place, that cause release of the oxygen in the atmosphere, as well as ATP and NADPH process are because when water becomes split or photolysis occur, what the electron become released, that become accepted by the NADP plus, so NADP plus and converted into NADPH plus S plus, and concomitant release of ATP. In the direct reaction what happened? What look at, and in case of the direct reaction what happened? Carbon dioxide is converted into carbohydrate, or CO2 is converted into C6H12O6 by getting electron from the NADPH plus S plus and energy of ATP. This is the fundamental idea about the light and dark reaction. Understood? Yes or no?
Yes.
Yes, sir.
Now tell me briefly, Atil, what happened in light reaction of photosynthesis? Anyone can speak in your own way also. Atil, what happened in photosynthesis light reaction? Hello? What happened? What happened in light reaction? कौन लाइट रिएक्शन कौन हुए फोटोसिंथेसिस रो लाइट रिएक्शन कौन भांगे कौन बाहरे
कार्बन डाइऑक्साइड ରୁ कार्बोहाइड्रेट ହେଇଥାଏ
अरे मूर्ख in light reaction what happen in light reaction water break water भांगे दा कुआ photolysis of water भांगी दे ऑक्सीजन बाहरे आ ATP और NADPH बाहरे डायरेक्ट रिएक्शन कौन हुए कार्बन डाइऑक्साइड टा NADPH S plus ରୁ इलेक्ट्रॉन निये ATP ର एनर्जी नै कि से कार्बन डाइऑक्साइड ना कार्बोहाइड्रेट हुए कि C6H12O6 हुए बुझ पाइले बे हेलो
Yes, sir.
look at these are the history. Okay, so the photosynthesis which occur inside the chloroplast, and then this is our the chloroplast. Chloroplast is bound by two membrane, outer membrane, inner membrane. Inside the inner membrane, our stroma present. Inside stroma, our the grana are present. Then is grana which consists of number of disc-like structure known as a thylakoid. In the thylakoid membrane, we are having a pigment systems are present. Look at these are the pigment. The chlorophyll A, B, carotene, zeaxanthin, which are found inside the photosynthesis apparatus. Look at then one word called absorption spectra and action spectra. Absorption spectra means amount of light absorbed by the photosynthetic pigment at different wavelength called as the absorption spectra of light. If in a single sentence or simple sentence, if you explain what amount of light energy absorbed by the pigment molecule or by chlorophyll molecules present in the leaf, known as absorption spectra. जेतिक लाइट टा तमर पिगमेंट माने शोषंती फोटोसिंथेसिस पाई ताको कोआ absorption spectra. जेतिक लाइट शोषिले सेतिक लाइट रे जेतिक फोटोसिंथेसिस हैला ताको कोआ action spectra. Got this point? Hello.
Yes, sir.
Look at this is the immersion enhancement effect. It is not possible to explain everything here. Okay. And simply here in the leaf, the pigment molecules which are present by organizing into photosystem. We have the two types of photosystem, photosystem 2 and photosystem 1. In photosystem 1, there is a central pigment is present here. This is not P700 or P700 known as the reaction center. The photosystem 2, P680 is known as the reaction center. भाभी दे एटी कोन हमर मेंशन पिगमेंट थिबे मझिरे गोटे देखो ई सब जा क्लोरोफिल अछंती आ मेंशन पिगमेंट अछंती सेंटर रह गेला गोटे क्लोरोफिल ताका हम कहै छै P680 कि जो क्लोरोफिल टा अब्जॉर्ब करछि मैक्सिमम लाइट एनर्जी at the wavelength of 680. Here this is a group of pigment molecule but a center there is a special form of chlorophyll A present who is showing maximum absorption माने बेसी लाइट सोसुची कोडी ना 700 नैनोमीटर लाइट अधे सोसुची सिटी में याको जे P700 or reaction center 700. Okay, now mechanism of light reaction. The mechanism of light reaction can be studied on the following heading. But first कौन हमरा absorption light energy by photosynthetic pigment. Then this implies that, and suppose we are having leaf. The leaf contains photosynthetic pigment. Has sunlight falls on surface of leaf, so ultimately on the pigment. Now all the pigment which absorb the light energy, all they transfer this light energy to the reaction center. In case of our the photosystem 1, the reaction center is the P700. Into the reaction center is the our P680. So all the transfer the energy by the process of FRET. FRET is known as fluorescence resonance energy transfer. The process known as FRET. This process of energy transfer from the accessory pigment to our the reaction center known as FRET or fluorescence resonance energy transfer. You have to remember these things. And when the light energy falls on surface, they direct the pigment molecules of the light energy and they transfer the center. After that, suppose there are about 220 to 230 chlorophyll molecules present in a pigment system. We are having two types of pigment system 2 and pigment system 1. In pigment system 2, the reaction center is P680. In pigment system 1, the reaction center is the P700. Suppose it may be pigment system 1 or pigment system 2. There are about 200 to 230 chlorophyll molecules present here. All the chlorophyll molecules absorb energy, and after that, all send the energy to a single chlorophyll molecule who is present at the center. Okay. Now tell me, this single chlorophyll molecule now having more energy. Due to the more energy, it becomes more unstable. Now it try to become stable. So it lose excess energy by expelling an electron. Got this point? Hello.
Yes, sir.
Look at, and then the electron that has been ejected, if the same electron that come back to the system, the photosystem where it was ejected is known as cyclic. If this electron is not come back to the system where it was ejected, is known as non-cyclic. भाभी लीफ रे हमर दीटा ग्रुप रे पिगमेंट अछनी गोटे ग्रुप रे 220 230 ना क्लोरोफिल अछनी दीटा ग्रुप हेक अछनी पिगमेंट सिस्टम 2 पिगमेंट सिस्टम 1 pH2 रे मुख्य आ कोना मुख्य क्लोरोफिल टा P680 and 1 है P700 टूटा मध्य थिबो. So we are having the two type of electron transport in our the photosynthesis, one non-cyclic and a cyclic. Actually non-cyclic is it is the light reaction. Non-cyclic, what happened here? This is the photosystem 1. This is the P700 is the reaction center. First light energy falls on surface of the here the photosystem. Now the electron from this particular the reaction center is become expelled. The expelled electron of the now is accepted by the electron carrier A0, then A1, FPSX, FPSA, FPSB, FD. And finally the electron of the P700 or photosystem 1 that become trapped in our NADP plus, and NADP plus converted into NADP S plus S plus. So electron that is ejected from the photosystem 1 do not come back to the same photosystem. Then so that here now in case of now here in photosystem 1 there's some electron deficiency now is here. So this electron deficiency of the photosystem 1 now become fulfilled by electron that are coming from the photosystem 2. The similar way, due to the heat energy, and then the electron become ejected from or expelled from the reaction center of the photosystem 2. Now for the number of electron carriers like pheophytin, quinone A, quinone B, cytochrome B6, cytochrome B, cytochrome A, plastocyanin, finally is the pigment system 1. So now the electron deficiency of pigment system 1 now become compensated or become fulfilled. But there's electron deficiency in the pigment system 2 right now. So electron deficiency in the pigment system 2 now become filled up by the electron that are coming from the water. So here water in presence of a protein complex known as oxygen evolving complex, which see break to form oxygen and oxygen, proton and electron. The proton come into the matrix, and whereas this particular the electron now come to the photosystem 2. Okay, and while look at while the electron are moving through the cytochrome BF complex, what amount of energy become or the free energy release that is sufficient to form a molecule of ATP pad here. And in the cytochrome B6F complex पाखे गोटे ATP तैयारी हुए. This is the cyclic means the electron that ejected from the photosystem 1 again coming back to photosystem 1. It's not cyclic. In cycling, no NADPH form, only ATP can be formed. The cyclic operate when non-cyclic is not there. When wavelength of light is more than 680 nanometer, only cyclic can operate. You have to remember this. Hello.
Yes, sir.
Sir.
Look at, and in case of the look at, and by the process of the light reaction, our ATP and NADPH have been formed that become utilized in the dark reaction to convert carbon dioxide to carbohydrate. In case of the dark reaction, there are the 3 steps of the dark reactions are there. One is carboxylative phase, then reductive phase, and a regeneration phase. In a carboxylative phase, the carbon dioxide first come, and that become react to the REBP. Carbon dioxide contain 1 carbon atom, REBP contain 5 carbon atom. Carbon dioxide REBP combine to form a 6 carbon atom unstable compound. They become split into 2 molecules of 3 carbon compound known as phosphoglyceric acid. Now this phosphoglyceric acid undergo the reductive phase. In case of the reductive phase, at the end of the reductive phase, we are having the glucose become result. After that, whatever left after the reductive phase, they become utilized in the regeneration phase to again produce the ribulose 1,5-bisphosphate. Look at, these are the main steps. This is the step of the carboxylation. This is REBP, carbon dioxide, and to form the two molecule of 3-phosphoglyceric acid. All these phase of the reduction. It is not possible to discuss everything. This is the cycle of the Kelvin cycle. Light reaction is itself the 2 to 3 class topic. Okay. Look at now here come to look at in case of the direct reaction or in case of the Kelvin cycle, which is the fast stable product. In Kelvin cycle, which is the fast stable product? In Kelvin cycle, which is the fast stable product? Which is, look at here, the REBP react with carbon dioxide to form a 6 carbon compound. This become break to form the 2 molecule of 3 carbon compound. So 3-phosphoglyceric acid. The 3-phosphoglyceric acid is the fast stable product of the Kelvin cycle, which contain 3 carbon compound. So they are known as the Kelvin cycle is otherwise known as what? C3 cycle. Okay, and then for a long time it was believed that, and then C3 cycle is the only pathway, but later we have discovered some C4 cycle or C4 pathway of carbon dioxide fixation. And the C4 pathway of carbon dioxide fixation was discovered by Kotask, Hart, Bohr, and then by Hatch and Slack. Look at, and in case of the C4 pathway, what happened? And then those plant in which C4 pathway operate, they are having a special type of anatomy known as Kranz anatomy. And in this case, what happened? And the simply here, look at, in case of the C4 pathway, what happened? This carbon dioxide first accepted by the phosphoenol pyruvate to form oxaloacetic acid. This oxaloacetic acid is a 4-carbon compound. And then being the oxaloacetic acid is a 4-carbon compound, this pathway is known as the C4 pathway. Besides, we are having also a C2 pathway. The C2 pathway is other known as photorespiration. So look at here, in case of the photorespiration, what happened? When in the environment, the high concentration of oxygen or oxygen level become high, and then carbon dioxide become low and high temperature. In this case, our C2 cycle or photorespiration start. In case of photorespiration, what happened? And then the Rubisco is the enzyme which first combine, generally in case of Calvin cycle, it combine REBP with carbon dioxide in case of the Calvin cycle or C2 cycle or the dark reaction. But when concentration of the oxygen become increased in the environment, the same enzyme Rubisco which combine oxygen with the REBP, and then to form our phosphoglyceric acid and phosphoglycolic acid. So that this phosphoglycolate is a 2-carbon compound. So it is known as the photorespiration or our C2 cycle. And then photorespiration is mediated by the 3 cell organelles, one is chloroplast, peroxisome, and a mitochondrion. And then due to the photorespiration, the extra carbon dioxide become released. This extra carbon dioxide and about the net release of normal carbon dioxide by the respiration, that increases the rate of carbon dioxide released during the daytime. And then the photorespiration implies that the rate of carbon dioxide released in presence of light is more than the normal carbon dioxide released at the night time. So the increased rate of carbon dioxide released during the daytime is called as photorespiration. Hello, getting my point? I think you are not getting this point because the time is very less, and here the light reaction 2 to 3 classes, bad reaction is itself a class, C4 cycle is itself a class, and then so that how could you manage to bring you understand? Okay, these are the steps. Look at, hello.
Yes, sir.
Hello.
Yes, sir.
Hello. Okay. Next come to our CAM. CAM is the crassulaceous acid metabolism. Then, and who are the CAM plant? Generally, those plants who are growing in the desert, like open soil, जो सब गछ गुरा हम डेजर्ट रे बढ़ंती, ସେମାନେ କଣ କରିବେ ଦିନ ବେଳା ସେମାନେ ଚାହିଁଲେ ବି ଦିନ ବେଳା ସେମାନେ ତାଙ୍କ ଷ୍ଟୋମାଟା ଖୋଲି ପାରିବେନି। କାହିଁ ଷ୍ଟୋମାଟା ଖୋଲି ସେମାନେ କଣ ହବ ଦିନ ବେଳା?
water loss
ହେଇଯିବ। ସେମାନେ କଣ କରନ୍ତି ନା ରାତି ବେଳା ସେମାନଙ୍କ ଷ୍ଟୋମାଟା ଖୋଲିବେ। ରାତି ବେଳା ଷ୍ଟୋମାଟା ଖୋଲିଲେ କଣ ହବ? କାର୍ବନ ଡାଇଅକ୍ସାଇଡ ଭିଡି ଆଣିବେ। କାର୍ବନ ଡାଇଅକ୍ସାଇଡ ଭିଡି ଆଣିକି ତାକୁ ସେ କଣ କରିବେ? ଅକ୍ସାଲୋଏସିଟିକ୍ ଏସିଡ୍ ସାଙ୍ଗେ କମ୍ବାଇନ୍ କରିଦେବେ। ସରି ନା ପିଇପି ସାଙ୍ଗେ କମ୍ବାଇନ୍ କରିଦେବେ। ପିଇପି ସାଙ୍ଗେ କମ୍ବାଇନ୍ କରିକି ତାକୁ ଅକ୍ସାଲୋଏସିଟିକ୍ ଏସିଡ୍ ସେ ନା କନଭର୍ଟ କରିଦିଅନ୍ତି। After that, they convert oxaloacetic acid into our malic acid. Malic acid କରିକି ସେ ଭାକ୍ୟୁଲେ ତାକୁ ଷ୍ଟୋର କରି ରଖନ୍ତି। ତା ରାତି ବେଳା ଅଧିକ ପରିମାଣ ଆମ ଏସିଡ୍ ହେଇଗଲା, ମାଲିକ ଏସିଡ୍ ହେଇଗଲା। ଠିକ ଦିନ ବେଳା କଣ କରିବେ? ମାଲିକ ଏସିଡ୍ ଟାକୁ ଭାଙ୍ଗି ଦେବେ, ହେଲା, ପୁଣି ରିଆକ୍ସନ ପୁଣି ଉଲ୍ଟେଇ ଦେବେ। ପୁଣି କଣ ହେଲା? ପୁଣି କାର୍ବନ ଡାଇଅକ୍ସାଇଡ୍ ବାହାରି ପଡିବ ଆଉ ପି ବି ବାହାରି ପଡିବ। ଯୋଉ କାର୍ବନ ଡାଇଅକ୍ସାଇଡ୍ ଆମର ନା ଦିନ ବେଳା ବାହାରିଲା, they utilize their photosynthesis। ତା ଅର୍ଥ ଦିନ ବେଳା ଷ୍ଟୋମାଟା ବନ୍ଦ ହେଇଥିଲେ ବି ତାଙ୍କର କିଛି ଇଫେକ୍ଟ ପଡିବ ନାହିଁ। ସେ ଯୋଉ ପ୍ଲାଣ୍ଟ କୁହାଯାଏ କାମ୍ ପ୍ଲାଣ୍ଟ। ଗଟ୍ ଦିସ୍ ପଏଣ୍ଟ? ହ୍ୟାଲୋ।
Yes, sir.
Look at here. During the night time, the stomata become open, so that here they cannot open stomata during the daytime. That ସେମାନେ କଣ ଯାହା ବି କରିବେ କାର୍ବନ ଡାଇଅକ୍ସାଇଡ୍ ଦେଖ, ଯଦି ସେମାନେ ତାଙ୍କର ଦିନ ବେଳା ଫଟୋସିନ୍ଥେସିସ୍ ହବ, କିନ୍ତୁ ଦିନ ବେଳା ଫଟୋସିନ୍ଥେସିସ୍ ପାଇଁ ଯଦି ସେ ଓପନ କରିବେ ଷ୍ଟୋମାଟା, ତାହେଲେ କଣ ହବ? ପାଣି ବାହାରି ପଡିବ, ଗଛ ମରିଯିବେ। ମରୁଭୂମିରେ ବଢୁଛନ୍ତି, ସାହାରା ମରୁଭୂମି ସେମାନେ ନା, ଫର ଏକ୍ସାମ୍ପଲ ଗୋଟେ ଅପିନ୍ସିଆ ଅଛି that growing in the desert, it cannot open the stomata. So to carry out the process of photosynthesis, it opens the stomata during the night time. fast. Night time kon hobo, it first be carbon dioxide, or it has stored maximum carbon dioxide as possible during the night time. So what happen here? It peak carbon dioxide. What if carbon dioxide become peak? That become peak converted into mallet by the process of the reduction. Mallet stored in the vacuum. During the night time, our acidification occurs. This is the what? Acidification. Because the malic acid is formed. Now come to the daytime stomata become closed. When but there is a photosynthesis, light reaction hobo kahi khara poduchi. Khara pole kon hobo? This malic acid ebe vacuum bahari pole asibo. Malic acid bhangi jibo to form pyruvate, then carbon dioxide. Then this carbon dioxide which become released, that become undergo Kelvin 3 cycle of the photosynthesis to form the glucose. But this known as the CAM plant or the CAM cycle, crassulation acid metabolism. So here is malic acid and oxaloacetic acid known as the crassulation acid. Okay.
Yes, sir.
Hello. Okay, then I'm also compelled to do that because photorespiration itself is one class, C4 cycle itself one class. Because the time is limiting, so just I'm giving just here I'm trying to give some summary. Hello. Then is there any doubt of anyone? Is there any doubt of anyone?
No doubt, sir.
No.
I know that, and if you understand everything, there is no doubt. If you do not understand anything, there is no doubt. If there is you understand something, there is some doubt. Then which category will come, or you will come?
Sir, we can say that.
Which category?
We cannot
Which
say that,
category will
sir.
come? What?
We cannot say that, sir.
Okay, okay. Not only finally, and whatever we have been discussed about the mineral nutrition, etc. Then have you got something or not?
Yes.
Okay, in this coming class, we have to start about our the respiration. Okay, respiration as well as enzyme.
In photosynthesis,
Okay.
there is lot of confusion because you are saying so much for so we did. I think I don't get anything. I will revise the note and I will let you know if any I have any doubt.
Actually, I'm not getting you. What?
In photosynthesis, there is lot of doubts because that part is going so
And,
fast.
and just we have look at, and just we have touched the topic of the photosynthesis, because what amount of time that is given by us, only the four classes to complete whole paper. Okay, and then in this photosynthesis, you have remembered that in the photosynthesis, plant prepare food material by utilizing energy of sunlight in presence of carbon dioxide and water. Okay, and in the leaf and with the help of the chlorophyll also. And the photosynthesis is accomplished by two processes: light reaction and direct reaction. In light reaction, plant cause photolysis of water. Due to the photolysis of water, then our ATP form, NADPH form, and oxygen evolve. So due to photolysis of water, the ATP form that store energy, NADPH plus form that store that electron. But in the direct reaction, the carbon dioxide become reduced into carbohydrate by getting electron from the NADPH plus S plus that produce in the light reaction and energy of the ATP. Okay.
After January,
After
there
that,
will
you have to study a lot
continue
regarding the
what?
photosynthesis. Actually, I don't have any idea. Only the 4 classes are given to complete this paper.
Yes, sir.
BBYCT 137 it is.
And then for each paper there is only 4 classes given, and if you only study the syllabus or the top or the simply, and if anyone read the topic, then it is not sufficient. You are the 4 class.
Yes, sir.
Yes, they also didn't provide the material of BBYCT 137 in online also.
And for that you have to ask the coordinator of the IGNO of Kendrapada Autonomous College. I think your study center is Kendrapada Autonomous College.
No, mine is
Then you
Barampur,
have to
Kalikut University. Barampur.
Collegiate University, and you have to ask them to provide you the subject or the study material. Okay.
Okay.
Or, hello?
Thank you for today's class.
Okay.
Yes, sir. Thank you, sir.
Yes, sir.
Yes, sir.